first talk of the session entitled Towards VEsNA Framework for Managing Virtual Environments by Natural Language Agents from Andrea, Gatti and Viviana Mascardi.
Good morning. My name is Andrea Gatti. I'm a student of computer science at the University of Genoa, and I'm here today to present you VEsNA, a framework for managing virtual environments via natural language agents. I'm working on together with Professor Viviana Mascardi, author with me of the paper proposed. Okay, let's start with an introduction. Consider the following scenario. Alice runs a small factory and would like to place new robots to increase productivity and wants to identify their safest configuration. A limited budget does not allow her to pay for the license of a commercial CAD or simulation tool, and she doesn't know how to use them. To ensure safety, she would like to anticipate what might go wrong with different configurations of robots. She needs a tool that allows her to, first of all, displace elements into a virtual environment via user-friendly interface based on natural language interaction in order to identify the best configuration. Then the tool has to check that displaced objects meet the hard and the soft safety and legal constraints related to their position and interaction, and provide a natural language explanation of why some constraints are not met by a given configuration and suggest alternatives. But these three goals might be achieved by adding a natural language interface on top of existing computer-guided design tool. Alice wants something more sophisticated. The tool should also run a simulation in the virtual environment, get statistics about them, and explain her using a natural language interface what may go wrong. And in a more advanced way, allow workers to enter the virtual and dynamic environment, interact with robots therein, learn what is safe and what is not, and get the most effective and realistic training with natural language explanation. So, the tool Alice is looking for should understand the command issued in natural language. Those commands might range from the simplest add a Yaskawa MA 2010 in front on the right to the more sophisticated add workers with some profile, for example, experienced, unexperienced, reliable. The tool should provide a chatbot-like natural language interface. Be aware of rules and be able to verify whether a given configuration that may include robots and workers meets them. The tool should be able to reason on facts represented in a symbolic way. For example, a robot is placed in this position and an experienced worker is placed in that position on their logical consequences and on the rules that might be broken by them. Be able to synthesize natural language explanation of its logical reasoning flow, besides reasoning and understanding natural language. Ensure a one-to-one correspondence between facts representing symbolic knowledge amendable or logical reasoning and object placed in a virtual environment, equipped with a realistic graphical interface where dynamic behaviors may be added. The tool should be suitable for running realistic simulations. In the end, allow the virtual environment to be made available as a virtual reality for training purposes, with no extra effort. To the best of our knowledge, no such a tool exists. The proposed paper moves the initial steps towards it by describing VEsNA, and implemented a general purpose framework for managing virtual environments via natural language agents. VEsNA exploits three different technologies, in particular, Dialogflow for building a chatbot-like interface, Giacomo for integrating knowledge coming from interaction with the user into a cognitive rule-driven agent able to reason about this knowledge and to provide the human-readable explanation. Unity for building the dynamic virtual environment and letting human users immerse in it. we can now start describing these three pieces of our work. Dialogflow is a lifelike conversational AI with state-of-the-art virtual agents developed by Google. It allows users to create personal chatbots, namely conversational agents, equipped with intents, entities, and fulfillment. The intents are used to classify received messages depending on the content. Each message is classified in one and only one intent, or an error message is produced. Dialogflow is trained to this with the sample sentences classified by the user. Then we have entities. Each entity has parameters that can be identified inside a sentence. For example, the entity person would have a parameter name, surname, and so on. Dialogflow is trained to find them, tagging them in the classified sentences used for training, the ones we cited. Last, fulfillment allows Dialogflow to request the question answer to an external source. It is enabled at intent level, so one intent can have it and another one answer directly without requesting nothing. Let's move. Giacomo is a framework for multi-agent programming that combines three separate technologies, each of them being well known on its own and developed for a number of years, so they are fairly robust and fully fledged. It is based on a belief desire intent architecture, and in particular we have beliefs, that is the set of facts the agent knows, goals, that is the set of goals the agents want to achieve, and plans, that is the set of precompiled operational plans the agent can use to achieve its goals. The connection between Dialogflow and Giacomo is done using Dialog4Jaka framework. Unity, last, is a cross-platform game engine that allows developers to create scenes and add the object to such scenes by dragging and dropping them from a palette to the scene. It allows to attach C# scripts to objects and to run physically realistic simulations. I will now present the architecture of VEsNA, starting from the beginning. Suppose a user wants to add an object in a 3D empty virtual environment. The user sends a message that is received from the Dialogflow. Dialogflow processes it, understands that the intent of the user is to add an object, and sends a message to the Giacomo agent. The Giacomo agent, for the moment, only forwards the request in a different representation to Unity. In future, Giacomo will become the core of the intelligence of the system, and this is why it's important to have it already in the middle of the process. Unity adds the object on the scene where it is visible to the user, and sends a message back that then returns back to the chat. Let's make a step back. This is an example of the Dialogflow interface, and in particular of the training sentences given to add an object. As you can see, in this case, there is inside them an entity, the object, that has some parameters tagged. This is the name of the parameter, this is the name of the entity. You select the text and you say this is X, for example. Okay, so Dialogflow receives, for example, this message, understands that the intent is to add an object, then identifies the object, the position on the y-axis, and the position on the x-axis. To place an object, the user has three possibilities on both axes with a global reference system. The user can choose between from, center, and behind for y-axis, and left, center, and right for x-axis. It is also possible to place objects with respect to the others already placed. Done this, it produces a message with the information extracted. This message is sent using the fulfillment feature to Giacomo that makes an HTTP request forwarding the information. On port 8081, a Unity listener is waiting for requests. Unity receives the information for the new object, makes the needed checks, in particular availability of the position. If a robot is already in the place where we want to put the new one, a failure event is triggered. Adds the objects and send back a message to Giacomo containing the agreement of the operation and the new unique name of the added object. In this case, Yaskawa MA20101. This name can be used to refer to that specific object, to place object near it, to remove it, and in future for more and more. Giacomo takes the message and creates a human-readable one that sends to Dialogflow. And this is the one that is shown in the chart. This is an example of how it looks like in our implementation. This is the factory we built for our simulation. This is the Yaskawa MA 2100, 2010. And as you can see, it is you can see the intent that has been identified, the parameters, front, right, the object name, that is the name of the robot you want to add, and the answer of the agent. Then this is another example. The user can also add the object with respect to other already placed. For example, here it placed the object on the left of the first one. The available position are left, right, behind, and in front of an object that is already placed. Last, the user can also remove objects. So, in conclusion, we presented VEsNA, a framework that allows the creation, the addition, and the removal of objects in a virtual environment, connecting 3 different technologies, Dialogflow, Giacomo, and Unity, that weren't connected to each other. In the future, the work will focus on make the objects intelligent, giving them intelligence with an agent behind, make employees available as agents that can be inserted in scene. And since VEsNA is a general purpose tool, there is also a lot of work in the direction of a theatrical storytelling tool. And last, we want to make use of open source frameworks. With this, I end the presentation. Thanks for your attention. And if you have questions, feel free to ask.
So let's see. Are you, Andrea, online?
Yeah, here I am.
Thanks. Are there any questions for Andrea? Yes.
So I saw that. I mean, thank you for the presentation. So in your Dialogflow, the sentence you give for the training are quite artificial, right? They are like very formalized as something at this point. Do you plan on using more diverse data sets so that the user can more naturally say things, or you want them to write the sentence in this particular way?
Well, at this time, the user has to decide the objects that it wants to put in scene, and it has to specify the names of them specifically. But in the future, it will not be so. For the moment, also the objects in Unity have to be added by the users by dragging and dropping them inside the C# palette. But in the future, I will like to make it available at Unity level. So the user inserts the objects in the C# script palette, and then a script produces the sentences for the Dialogflow training. So I don't know if it was the question, but this is the idea behind, more or less.
Okay. And maybe the second follow-up question is, is Giacomo handling common sense? For example, if you say, oh, I want this object to be in front of this one, does he already understand that, for example, if there's already an object, it shouldn't overlap with the object, or any kind of common sense for placing objects?
Yeah, Giacomo for the moment only forwards the message, but in the future he has all the knowledge about the scene and about how an object can stay in front or behind or near something else. So then Giacomo will also be part of the process of adding by adding some information to the addition process. I don't know if Angela would like to add something. I can't hear very well the questions, so
I think that the question was answered very well. Okay, so thank you very much again, Andrea.